Good day. I'm Andy Purvis, and I am Director of Safety, Environment and Technology with the World Steel Association. And I am delighted to join the Asia Steel Forum today to talk about carbon neutrality and the future of the iron and steel industry. So my presentation today is going to look a little bit like this. I'm going to start off talking about carbon neutrality and what it means. We're then going to look at the state of play in terms of the regulation and international agreements around CO2 and climate change. We'll look at the role of steel as part of the solution, but then look at World Steel's three-step approach to mitigation of emissions from our sector. We'll take a quick look at the broad portfolio of technology options that are being developed to decarbonize emissions from our industry, and close looking at the importance of partnerships and enabling framework really to facilitate the transition that our industry needs to make over the next 30, 40 years. Let's start with thinking about the carbon cycle, because when we're talking about carbon neutrality and net zero, I think to understand this is really important. So CO2 exists naturally in the atmosphere. It always has. And the natural photosynthesis process brings CO2 into plants and then sequesters it in the land, in dead organisms and waste products, which may eventually become fossil fuels. CO2 is released as animals breathe through changes in land use and fires, for example, through plant respiration and other geological processes such as volcanoes. Now, generally, if you think about the natural carbon cycle, there's a fairly good balance between emissions and absorption on a global basis. There are sometimes imbalances, and the climate has changed, but this generally happens over geological time periods, so very slowly compared to the pace of change that we're looking at the moment. So what's changed? Well, our forefathers in the 19th century discovered fossil fuels and discovered that they could use fossil fuels. And indeed, the use of fossil fuels has completely changed our societies and allowed many countries around the world to industrialize, improving the lives of many people around the world. However, the negative side of that is it's released a lot of the CO2 and carbon that was previously locked up deep underground in fossil fuels. This has been released to the atmosphere at a rate significantly more than the natural carbon cycle is able to absorb. Consequently, we've seen increases in CO2 levels in the atmosphere, really since the start of the Industrial Revolution. And this is a problem because there's a very close relationship between atmospheric CO2 concentrations and temperature. I think this is shown very clearly in this graph, which shows, you see the line showing the increase in atmospheric CO2 levels since around about the 1880s, as we use more and more fossil fuel around the world. And you can see average temperatures compared to the long-term average. So as CO2 levels in the atmosphere are increasing, we see the Earth getting warmer and warmer. The challenge we have as a society and as an industry is how we resolve this. Now, in some ways, the answer is simple. If we want to prevent the release of further CO2 to the atmosphere, we need to stop using fossil fuels. Now, clearly, given our entire society is built on the use of fossil fuels, hydrocarbons, and coal, a change of that nature cannot happen instantly. But this is the challenge that I think our industry faces, and I would like to spend the rest of my presentation exploring what this means and what this could mean for our sector as we move forward to 2050 and beyond. What's the state of play now? When we think about climate change, the Paris Agreement is the first thing that comes to mind. That the Paris Agreement is the legally binding international treaty on climate change, subsequently supplemented by the Glasgow Climate Pact this year. The Paris Agreement was adopted by 196 countries at the United Nations Climate Change Conference, COP21, in Paris in 2015, and it entered into force a year later. The goal of the Paris Agreement is very clear. It was to limit global warming to well below 2 degrees, preferably to 1.5 degrees compared to pre-industrial levels, so where the Earth was before the Industrial Revolution and we started using fossil fuels. However, having said that, I think the debate has largely moved on from 2 degrees. The focus now, 6 years later, in 2021, is entirely focused on 1.5 degrees. And we're seeing a spreading commitment to net zero by the second half of the century from countries around the world. For example, the EU, the US, South Korea, Japan, the UK have set net zero targets for 2050. China and Russia have set net zero targets for 2060. And more recently, India, during COP26 in Glasgow, set a net zero target for 2070. If you look at where steel is made now, more than 90% of our current steelmaking capacity is in countries that have set net zero targets. Also, those countries account for 90% of world GDP. And I think the focus of the discussion around emission reduction has also shifted and changed. Earlier, we'd talk a lot and hear a lot of talk about energy, the electricity system and transport. My feeling is now we're hearing a lot more around hard to abate sectors. And I would certainly put the steel industry in that category, as do many others, along with cement, chemicals, aluminium, heavy transport, those kind of industries. Steel it's ubiquitous. It's an incredibly useful material. In many ways, it has made the modern world possible. However, the production of steel is an emissions-intensive activity. On average, for every ton of steel we make, this leads to the emission of round about 1.85 tons of total CO2, including energy and so forth that we buy in. So if you multiply that by the amount of steel that we make, total direct emissions, so that's emissions just from our facilities into the atmosphere, are typically on the order of 2.6 billion tons. And this represents between 7% and 9% of global man-made CO2 emissions. So we are responsible for a significant proportion of CO2 emissions, and I think there's a lot of attention on our industry because of this. So we see countries making commitments, but we see steel companies responding. And this is the good news. Around the world, steel companies are making their own commitments, reflecting, and I think, on the commitments that many governments have made. So, for example, and these are all examples, there's a lot more than this. In the United States, companies like Nucor and United States Steel have made commitments to reduce their emissions or hit carbon neutrality. Across Asia, Nippon Steel, POSCO, JFE, Baowu, Baotao, HBIS, major steel manufacturers, all setting 2050 neutrality targets for their companies. Global companies like ArcelorMittal are doing the same thing. And often it feels like every week there's a new announcement from a steelmaker. So our industry is definitely responding and making commitments. We're part of the solution. I think that's pretty clear. If I think around our material, steel, in many ways, it's the perfect material for the circular economy. It's easily recyclable, but steel can also be remanufactured and reused. So in many ways, it's a great fit. Also, modern steel products will be required to decarbonize the modern world. We know that most of the solutions that are being looked at, including electrification, whether it's of mobility or industrial systems, they're steel intensive. Renewable energy, carbon capture and storage, all steel intensive. Steel is a modern product and it will continue to be demanded by society. However, making steel produces CO2. And as a response, as an industry, we have a responsibility to reduce our own impact. And it's not, I think, a responsibility that we are shying away from. It's one that we're addressing straight on. And we're doing that through our World Steel's three-step approach, which I would like to talk you through now. The challenge we have is steel's useful. In fact, steel's essential. And we'll need more steel as we go forward because steel will enable the world to decarbonize. At the same time, globally and individual nations are making net zero commitments, be it for 2050, 2060, 2070, or potentially in some cases beyond that. You put these two things together and there's a squeeze. There's a squeeze of increased demand while at the same time reducing overall emissions from our industry. This means that the emissions intensity of a given ton of steel needs to significantly increase from where we are now to 2050 and beyond. The good news is we do have a plan, a strategy to achieve this, which I would like to talk you through now. The first element is efficiency. This is around making sure that every ton of steel that is produced as efficiently as possible. Well, the International Energy Agency certainly recognized efficiency in terms of process and product efficiency as a key lever between now and 2050. And our program, our Step Up program, is designed specifically to support our industry in improving process efficiency and really engaging with and supporting all of our members to bring average industry performance to where the top performers are now. World Steel has a wealth of data and information, and through detailed analysis of that, and especially detailed analysis of the data related to the very best performers, we've identified 4 key levers. They are optimal raw materials choice and use, increasing energy efficiency, minimizing waste, improving yield through our value chain, and improving process reliability. This is an absolutely key activity in the short term. Companies can and should be focused on their efficiency right now. Second step is around scrap. Scrap steel is an essential element, an essential input to the steelmaking process. Every steel plant is a recycling plant. But steel is made and it goes into use, and typically it sits in use for 40 years or so. It says that there is a limit to the amount of scrap steel that's available. It's a function of the steel that was made on average 40 or 50 years ago. Now, the good news is going forward, as we saw previously, there was a huge increase in the amount of steel that was produced in the early years of the new millennium, particularly driven by increases in production in China. This steel, this millennial steel, is in the next 20 years going to come to the end of its first life and become available for recycling. So we expect to see a significant increase in scrap available for recycling. Put that in context, 2018, there was around 400 million tons of steel scrap available. We expect this will increase to closer to 900 million tons by 2050. So it's going to more than double. This steel will make a huge impact because every ton of steel we can recycle, we don't need to make from virgin iron. Now, these are both important elements, efficiency and scrap, but they are not enough by themselves. To make the really radical reductions that will be required, we need to completely change the way we reduce iron ore into liquid iron. Right now, we use the DRI plant, which is generally gas-based, or the coal-based blast furnace. This will change. Now, there are other ways you can reduce iron ores, and they fall into 3 broad categories. The first is to continue to use carbon, as we do now, but prevent the emission of fossil CO2 to atmosphere, which is contributing to global warming. We can do this in a number of ways, using CCUS to take the CO2 or fossil CO2, lock it away, sequester it underground or in products. to use sustainable biomass to create a virtuous carbon circle, that way preventing those emissions. The second possibility is to use hydrogen rather than carbon as our main reductant. Producing steel using carbon produces CO2. If we can use hydrogen, we produce H2O, or water, as the main emission source. And the final choice would be to use electrical energy directly through an electrolysis-based process. And this is really how most primary aluminium is made now. Now, there isn't a silver bullet. There is not one single technology that will make sense in all companies, in all countries. And which breakthrough technology to deploy will very much be determined by the conditions and availability of resources or policy support in a given country. But there are a portfolio of technology options which are being developed around the world, and I would like to share some of those with you. These can only be examples. There are research projects happening across the continents within Asia, the US, Europe, North America, South America, looking at these different technologies using hydrogen, carbon, electricity. My time is limited today. I could talk for a very long time just about hydrogen, but I'm going to try and just give you one example of each type of project to give some context. But if you want to find more information, the World Steel website contains a wealth of information on what's happening with these technologies. I'll start with hydrogen. Hydrogen can be used, produces water and not CO2. And there's development close to home as I sort of virtually visit Asia to give this presentation. HBIS are a good example. They're building a 1.2 million ton capacity hydrogen metallurgy plant in China, expected to come online very soon. An exciting development. We also see developments with hydrogen happening across the rest of Asia and China, but also in Europe, where there's a number of companies looking at this and developing solutions. We talked about biomass, another way of preventing the emission of CO2 to atmosphere or fossil CO2. Aço Verde Brazil is another great example. They are an integrated steel plant in Brazil who are using sustainable biomass to make virgin iron and steel products in a carbon neutral manner. Across South America, biomass is used. There's also interest in using biomass in other countries with good fossil resources and well suited to growing timber and other potential materials, such as Canada, Russia, and Australia have come up as examples. CCS is about capturing CO2 and storing it underground. In Emirates Steel, in Abu Dhabi, in the UAE, there's a plant that can capture right now up to 800,000 tons of CO2 a year and inject that into mature oil fields, locking it away permanently underground, effectively putting the CO2 back where it came from, where the gas was in the first place. Renewable energy is also used around the world. Here's an example, and it's just an example. Evraz Rocky Mountain Steel in the US, they're moving their plant from using coal as a primary energy source to renewable energy through solar farm. Other companies in China, and I think of Nucor in the US, have signed power agreements to run plants entirely from renewable energy. Electrolysis, we touched on. This is a technology, I think, that's in the early stage of development. ArcelorMittal, though, are looking at using a project called AcidaWin, a low-temperature, water-based electrolysis system to take iron ore and turn it directly into iron. Another company, Boston Metals, are developing a higher temperature, molten salt-based project. And finally, CCUS, Shugang in China have developed a commercial facility to convert the processed gases from iron steel making into ethanol. And ArcelorMittal are building, as we speak, a very similar industrial scale product plant in their plant in Belgium. I think it's really important to appreciate that there isn't and won't be a single technology which will solve the decarbonization of emissions issue from the steel industry. There'll be different regions around the world in which different technologies will make sense based on the availability of resources, of government policy, and all kinds of markets, customers, all kinds of things. There won't be a single solution. However, I think one truth is that low carbon steel production, however we do it using all of these different approaches, it's going to cost more than steel production today using coal or natural gas. And in their roadmap, which they produced last year, the International Energy Agency estimated the additional cost to make a ton of steel using these low carbon breakthrough technologies would be between 10 and 50% more than it is now. This is a significant cost increase, and I think generally exceeding production margins within our industry. So we will have a period in which we'll have steel produced using these radical new technologies competing in the same market as conventional steel, which has been produced using a blast furnace or a more conventional route. This does potentially create a first mover disadvantage, and therefore we will need support from governments to make these new technologies, these radically different approaches, attractive and investable as we go through this rollout phase. So I think to close, partnerships are going to be really important, and also the enabling frameworks in which steel companies operate. Partnerships are fundamental, and it's something that I think our industry is good at. But moving forward, they'll become, I think, increasingly important. Governments, the steel industry, and other stakeholders looking up and down the steel value chain and around the steel ecosystem will all need to work together to overcome these challenges, the challenges involved in completely transforming our industry over the next 50 years. What will we do? Well, in the first case, we'll mitigate our own emissions. We will take the 3-point plan and use efficiency, scrap, and ultimately deploy breakthrough technologies to make steel and iron in a completely different way, reducing our CO2 emissions. We will create partnerships for transformation. We're good at creating partnerships. We're good team players. We will engage with governments, with our suppliers and our customers. And we'll be transparent. We will continue to measure and report on our emissions and report on our progress as we move through this story of reducing emissions from our industry. We need the support of governments, and we need governments to create policy frameworks that don't pick winners and losers among technologies, but help the most appropriate technology grow and develop in a given region. We do need governments to make sure that low carbon resources are available and affordable. I'm here thinking about things like hydrogen, low carbon electricity, and CO2 storage infrastructure. Governments can really assist in enabling access to finance for the transition. We'll need to make huge investments in capital goods over the next 50 years. Everything needs to change. And also, governments can play a role in reducing this potential first mover disadvantage by really creating or supporting a demand for low carbon materials like steel, and help to create a market, to create this market pull. Governments need to take an innovative approach to regulation. These are new technologies, and they may need to be regulated differently and more creatively, and take a life cycle approach, and certainly support the circular economy and recognize, I think, the role that steel plays, and steel's uniquely well positioned to play a role in the circular economy. And finally, to support collection and sorting of end-of-life steel products. Every ton of steel scrap, an extra ton we can get, we can use, and that will reduce the need to make steel, virgin iron, and reduce emissions accordingly. Finally, our customers also have a role to play. We need our customers to demand low carbon steel, but at the same time, understand that this low carbon steel will come at an additional cost compared to what they're paying now. We need customers to think about the entire life cycle when they're designing their steel containing products, and design products that are suitable for remanufacturing, reuse, and ultimately disassembly and recycling, and support the collection and sorting of end-of-life steel products. I think I'm going to finish there. If you're interested in finding more about World Steel, the steel industry, and our approach to climate change, please take a look at our website. There's a whole new section there focused on climate change. You can find fact sheets. You can find our policy paper. There's news of member initiatives in related areas, including new business practices, new technologies, new partnerships. And there's also information and links to work being carried out by other reputable organizations such as the International Energy Agency, Responsible Steel, and some others which are really looking at our sector. It's been delightful to join you today. I'm just sorry I can't be there in person, but I hope my presentation has been helpful. If you have any further questions, please do not hesitate to get in touch with me to the email address on the screen. And I would like to wish you every success with the remainder of your conference. Thank you very much for your attention, and goodbye.